Hello. Today we're going to talk about three concepts about how to write numbers that normally uh, give some trouble to students and create some confusion. The concepts of decimal places, significant figures, and standard form, standard notation, scientific notation, and scientific notation, which can be called either way. Okay, standard form is normally from the UK, and the rest of Europe call it scientific notation. Okay, so first of all, decimal places. Well, we all know what decimal places are. They are the places after the decimal point or comma. It depends on which system your country uses. So we're going to use uh, a point now, a full stop. So here we have a number with two decimal places because there are two figures after the decimal point. If we um, if we want to write a number with one decimal place, for example, this is a number with one decimal place, and we can have uh, a whole set of decimal places. Here we have 2, 4, 5. Okay, so decimal places are literally the places or the figures after the decimal point. So if someone asks you to write 3.14615 in decimal in with two decimal places, you have to write it up to here. So you need to know in decimal places how to round up numbers. So in decimal places, you need rounding up or rounding down, rounding numbers. So the rule is very easy. If the next number is less than 5, you leave it as it is. Okay, you just delete the rest of numbers that there are. And if the next number is 5 or greater than 5, okay, so we add 1 to our number. Okay, so an example. If we have the decimal number above, which is 314615, and we wanted to round it to um, two decimal places. So two decimal places would leave us 314. The next number is a 6. As it's a 6, we have to add up 1 to the previous one. So it's 3.15. Okay, so that's two decimal places. If we wanted to round up that to one decimal place, it would be 3.1 because this is just one decimal place. The next number is a 4. It's less than 5, and so we just delete everything and leave it as it is. Okay, that's the most common way to round up numbers. Uh, as you go on, you've discovered that the second rule is sometimes changed a bit, and we decide if it's an odd or even number or whatever. But the most common way to round up decimal numbers is this one. Okay. So this is decimal places. What does significant figures mean? Okay. Significant figures it's a concept that depends a lot on the precision of instruments. Okay, so for example, if we have a ruler that measures centimeters, okay, and we want to measure something like this, we could speculate that this is 1.2, 1.1, but we don't really know it because the precision of our instrument just measures 1 centimeter. Okay, So and we say that the error in that instrument is half of the precision, so it's 0.5 centimeters. Okay. So this means that if we measure this, we decide that our measurement is 1 plus minus an error, which is 0.5. So we decide that our measurement is somewhere between 0.5 and 1.5. Okay, so the precision of our instrument is 1, and the error we can make is half of the precision. So the number of the significant figures relates to that precision. If we want to give a measurement here, we can only say it's 1 or 2 or 3 centimeters. So those are our significant figures. However, if we had our ruler with more precision, something like this, okay, we could here say that something measures 1.2 or something measures 1.3 because our precision allows it. Okay. Again, here we could say that, for example, this is 1.3 plus minus half of the precision, which is 0.05. Okay. But our significant figures are 2 because I can measure with that precision. Okay, so basically the significant figures are referring to the precision of our instrument, and they're very important because they are significant in many ways. In that I can assure you that that's the number, that's the precision I can measure with. Okay, so. And for significant figures, you have to understand when figures are significant. I'll give you various cases. Okay, so significant figures. So any non-zero number is significant. Okay. So, for example, the number 3125 that has 4 significant figures. Okay, and the 283.847 that has 1, 2, 3, 4, 5, 6 significant figures because they're all non-zero numbers, and we decide that if we are using those numbers, they're all significant. Okay. Uh, this is if they give us this number, not if we calculate it. If we calculate it, we have to relate to the significant figures that we need to express it in, and it's normally the lowest of the significant figures that they have given us in the exercise. So if we have zeros, okay, uh, any zero between non-zero numbers are significant. Okay, so for example, the number 98908, this one has 1, 2, 3, 4, 5 significant figures because that zero is significant. If I am writing it like this, this implies that I know that that figure is a zero and not a 1, a 2, or a 3. Okay, uh, zeros. What happens with decimal numbers? Okay, so zeros after a decimal point are significant. Okay, because it means that my instrument, if I give those numbers, it means that I know that my instrument can provide that precision. Okay, so for example, 89.00, this has 4 significant figures. Okay, um, in decimal numbers, zeros before a non-zero digit are not significant. okay? Because I don't know, um, they don't really express the precision of my instrument. The only thing I am sure here it has a 9. So this is one significant figure, and 0.10, this has two significant figures. Okay, this one and this one, because the one before does not count. Okay, and 0.01, this one has one significant figure. Okay, and then if you there's another rule that if you round up numbers, the zeros are not significant. Okay, so for example, if we have 151840 and we round it out to we round it up to 1, 2, 3, 4, that has one significant figure. Okay, those zero do not count. Because I'm supposing that my apparatus can only measure uh, from the tenth, that's thousands, yeah, from the 10,000s, and not with more precision. Okay, but if I round it up to um, 518, for example, this has three significant figures. Okay, so significant figures mean the precision I can provide the number with, and they're very important. Okay, and they're related to, as we said, decimal places. In that we need to use how to round up numbers, etc., and know when they're significant figures, but they're not the same. In an exam, you might be asked, for example, to round up 2.351, um, round them up to, for example, to two decimal places, and that is 2.35. That's two decimal places. But if you want to round it up to two significant figures, that's 2.4. Okay, because that's a 5. Because these two are significant figures. Okay, so be very careful with that because it's not the same. And then the next part is scientific standard notation, also called, that's in the UK. Okay, it's normally called in the rest of the world scientific notation. And this is a way to write very big numbers or very small numbers in a tidier and more easy to read way. Okay, so for example, and it consists, first of all, of a number between 1 included and 9 included. Sometimes you can see this, which is the same as where we don't include the 10. So the numbers have to be between 1. I prefer this one because you can see that the numbers have to be between 1 and 9. Okay, you can't use a 10. Okay, and the number is written in this way, a times 10 to the power of n, where a is one number between 1 and 9, both can be used, and n is the number of decimal places we must move to convert the number into this form. Okay, so for example, if we have 0.000 321, okay, and we have 32156, these two numbers. Okay, that's A and that's B. If we wanted to write A in standard notation, we want to move this to the left. So when we write 3.2, we normally use in standard notation, although they have to tell you there. I'll leave it like this. Okay, we normally use two decimal places, but I leave it as it is. Okay, so 3.2156, and I have moved 1, 2, 3, 4 decimal places. to the left. Okay, so when we move to the left, it's positive. You can always see if you've done it correctly, because if you multiply 3.2156 times uh, 10,000, which is this, you obtain 1, 2, 3, 4, the same number. Okay. As you see, I'm writing two full stops here, and this might be confusing. That's why sometimes we do this in order to not get confused by when it's multiplying or when it's not. If we write it down like this, we don't need to use a comma. Okay. Those are three ways of writing the same thing. Okay. If we wanted to, and I've used here a comma because I use a lot the small point, the point as a multiplier. So I'll write this. So if we wanted to write 0.000321 in standard form on scientific notation, we have, again, it has to be 3.21, and we've moved 1, 2, 3, 4.4, but we've moved it to the right. Okay. So what does this? That's why it's a negative. So really, this would be the same as 3.21 divided by 234, 10 to the power 1, 2, 3, 4. And if we do that in the calculator, we obtain 0.000321. Okay. I'm just writing that down so that you know that it's the same, but the scientific notation is this one and that one. Okay. And again, you can write this down as 3.21 times 10 to the power of minus 4. Okay. So again, scientific notation is a way to write in a clearer way very big numbers or very small numbers, and in a way that we all understand, because it's standard all over the world, and it allows us to then see what we're writing much clearer and not have to write so many zeros. Okay, you have to understand that in science sometimes you're writing numbers. So for example, if you're using the Avogadro number, that's 6.02 times 10 to the power of 23. Okay, so that's 23 zeros after, so that's, we'll put 21 zeros after that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so if instead of having to write all this, it's much easier to write this. Okay, so that's why and the same happens in very, very small numbers. So that's why we use the scientific notation or standard notation. Okay, so I think after this video, you should understand the difference between the number of decimal places and how to round up. And if we don't need to approximate something around it to 1, 2, 3, 4 decimal places. What are significant figures? Its relationship with the precision of the instrument, and that they're called significant because they imply that you are able to confirm that those are that's the number, because your precision of your instrument provides you that number, and which numbers are considered as significant figures or not, and how to approximate things to 1, 2, 3, 4, 5 significant figures, and what is standard notation or scientific notation, and how to write it when it's a small number or a big number. Okay, so I hope you liked the video. You can hit on like on the channel, or subscribe, and we will be having more videos coming up. Okay, thank you.